How does mitochondrial dysfunction cause CFS brain fog? Imagine your brain as a busy city that needs a constant supply of energy to keep everything running smoothly. In people with chronic fatigue syndrome or myalgic encephalomyelitis, the energy factories in their cells, called mitochondria, aren't working properly. Mitochondria are responsible for making the main energy molecule called ATP, which powers all cell activities, including those in brain cells. When these mitochondria don't produce enough ATP, the brain doesn't get the energy it needs to function well. This energy shortage can cause the mental cloudiness and forgetfulness often called brain fog. In CFS and me, mitochondrial problems mainly involve a process called oxidative phosphorylation. This is how mitochondria turn nutrients like glucose into ATP. Research shows that in these conditions, mitochondria are less efficient at this process, leading to lower ATP levels. This means brain cells don't have enough energy to do their jobs, which can make thinking, remembering, and concentrating much harder. The severity of these symptoms often matches how much mitochondrial function is impaired. Several factors contribute to this mitochondrial trouble. One is that mitochondria might not get enough fuel like glucose, because the body's ability to absorb or use these nutrients is impaired. Normally, when energy is low, a protein called AMP-activated protein kinase helps increase glucose uptake, but in CFS and me, this response can be blunted. This limits the fuel supply for mitochondria, making energy production even worse. Inflammation also plays a big role. Elevated levels of inflammatory molecules called cytokines can interfere with mitochondrial activity, effectively shutting down their energy-making processes. This inflammation may be especially intense in the brain, worsening mental symptoms like brain fog. Oxidative stress is another culprit, where an imbalance between harmful reactive oxygen species and protective antioxidants damages mitochondrial components, reducing their efficiency further. Some patients even have mitochondrial DNA abnormalities, which can impair the mitochondria's ability to produce energy properly. Additionally, decreased glycolysis, the process that breaks down sugars into smaller molecules for energy, can limit the raw materials available to mitochondria. This is especially relevant in immune cells but may also affect brain cells, compounding the energy deficit. All these issues lead to a significant drop in the energy available to brain cells, which are high energy demand organs. When neurons don't get enough fuel, their ability to communicate, process information, and store memories is compromised, resulting in the mental fog so common in CFS and me. Understanding this connection highlights why pacing activities is so important. Overexertion can worsen mitochondrial dysfunction and deepen brain fog. Supporting mitochondrial health through balanced nutrition, managing inflammation, and reducing oxidative stress can help, but these strategies should always be discussed with healthcare professionals. Every person with CFS or me is different, so personalized care is key. In essence, mitochondrial dysfunction causes brain fog by impairing the brain's energy supply. When mitochondria can't produce enough ATP due to metabolic, inflammatory, or oxidative issues, brain cells struggle to perform their normal functions. This energy shortfall leads to the cognitive difficulties many experience, like trouble concentrating, memory lapses, and mental sluggishness. Recognizing this helps us understand why managing energy levels and supporting mitochondrial health are vital parts of coping with brain fog in CFS and me. Always consult with your healthcare provider for tailored advice and treatment options.